In this lesson, we introduce the fundamentals of Power BI data modeling. You will learn what data model actually is, the difference between fact tables and dimension tables, how transaction tables store numeric data, why aggregations like sum and average matter, and how relationships connect tables to build meaningful reports. Let's dive in.
Okay, so open the file. So in the morning, while you're fresh, you don't have to do much. It will be a lot of probably new information that I will, throw your way around data modeling, theory of data modeling. If you don't have much experience with data modeling, it will be some new terminologies that I will introduce. So if it gets overwhelming, that's fine because once I introduce the theory, then we are going to see some practical applications of it. So you are going to see example and things will start to make sense. So if it does not make sense first time I say it, that's okay. Just write it down because I will explain it with an example. I will say it differently, and at some point it will start to make more sense. Okay, now let's start with the same diagram, right? Which is consolidation of the data, right? That's also one of the steps we perform in data analysis, this entire cycle of data analysis. And in Excel, we flatten it, we flat the file, and in Power BI, we have to create a data model, not a database, a data model. And one thing that I've been saying was in a data model, it's more about understanding what to make flat, which is what to merge, and where to keep it separate and connect using a relationship, right? And that understanding comes from understanding two categories of table. And now I want to know how many of you have heard these terminologies, a fact table and a dimension table. So if you don't know about these terminologies, thumbs down, because those will actually allow you to understand what to merge and what to keep separate and how do you connect the data model together. Okay, so let's start by a very simple definition of a data model, right? The one that I like, there are so many definitions of a data model, but this one is really simple, really easy to understand. I like it. So data model is two or more, right? Data sets connected via linked. That's really a data model. And the process of creating a data model is data modeling. Now, there are two important elements in a data model, data sets, right? And a relationship. Within data sets, you have two very important categories of data sets. And once you understand the category, you start to know how do you restructure all the data sets which are coming from the data sources to create a fact table and a dimension table. Okay, let's see what those categories are. As I've just said, category number one is your right fact table. Fact and dimension are a very common terminologies used within Power BI ecosystem. But there are other terminologies which are also used for fact table, which is some people call it data table. You can also call it transaction table, right? And then similarly, for a dimension table, we have some terminologies. What are those? Especially for the business users, you might be familiar with lookup table. Have you heard this terminology? Or reference table or master data? Very similar concepts. These are the two broad categories. Once you understand these categories, it's also important for me to explain some characteristic of these tables. And now I want to just just say that this is not a hard science. These are characteristics, not hard and fast rules. Sometimes these will break and sometimes these will. Whatever I'm going to say will be true majority of the cases. I'm going to explain a general and typical scenario, but this will not be true 100% of the time. Okay. Some characteristic of a fact and a dimension table. A fact table is generally of this shape, right? Which means it's tall and thin. It means more rows, right? Few columns. Okay, that's all it means. And then also it has quite a lot of numeric data or quantitative data, right? Quantitative data. Whenever you have a quantitative data, logically, it also means that you're going to create a lot of calculations on it, right? Which is using, which is, if I have to specifically say, it means you're going to create calculated columns and calculated measures, right? These are the two types of calculations you can create using DAX. You can create a calculated column and you can create a calculated measure, which also means that when I use this table in my report, like what is the reporting purpose of the table? Because everything that we are doing since yesterday, my final outcome is a report, right? My final output is a report. So what is the reporting purpose of a fact table? Aggregation or summarization, right? I'll give you an example. So in this case, we have a sales table, which is the fact table. We have a unit price and a quantity. I multiply both of them to get, and both of them are numeric column, by the way. I multiply both of them to get a revenue. And then when I put my revenue on the report, I get total revenue, aggregated revenue, summation of the revenue, correct? Just to give you an example to make a point. Fact table, quantity and unit price at the numeric column, I multiply both of them to create a calculation which gives me revenue. And when I drop a revenue inside the report, it gives me total revenue. So the purpose is normally aggregation, summarization. What are the other aggregations we will have? Give me some examples.
Divide,
What's
subtract,
that? No,
division.
no. Aggregation.
So you want sum, average,
Correct.
percentage.
Think of it like this. You have a column, right? You have a column. How can you convert a list of values into a scalar value, right? When you sum it, it becomes one value. When you average it, it becomes one value. You count it, it becomes one value. You count distinct, it becomes one value. Min becomes one value. Max. So these are some of the common aggregations. Sum is the default aggregation, right? Sum, average, count are the important ones. When you go more statistical, it becomes standard deviation and variance and so on and so forth. But these are the common ones. Make sense? What kind of information does it record? What kind of information does it store? Oh, lost it. Anyways, that's fine. Let's start with fact. So we have few columns, numeric, right? Calculations, and then aggregation, right? As you can see, it logically connects numbers, calculations, aggregations, and by aggregation, I mean sum, average, count. What kind of information does it record? It records transactions, right? Something happening, right? It records events, it records activity, it records something happening. You are in in a department, you are in a company, and that company is performing an activity. It records that activity. If you're in sales, it records the activity of performing sales. If you are, completing the jobs, it records the activity of job completion. So it records some kind of an activity. And because it records an activity, it has date or multiple dates associated with it, which is your transaction date. And because you can have multiple layers of the transaction, like you can have a start of the transaction, a midpoint of a transaction, end of a transaction, like invoice date, payment date, promise date, right? Invoice due date. You can have multiple transactions, so it can actually have multiple dates. What else? Another way to look at it is a constantly growing table. It keeps on increasing. It keeps on having more and more rows at the bottom of it, which also means we have to refresh this one more frequently. But dimension tables, we don't really have to refresh that frequently. Although we do have to refresh from time to time, but the frequency of refresh is not that high because it is not growing constantly. But your fact table keeps on having more and more rows. In our example, we have a sales transaction table. Every day, we are selling hundreds of items, hundreds of transactions. So those are the rows which are getting added at the bottom of it. Make sense? It is a constantly growing table. And then it also has what we call foreign keys, right? I'm going to get to foreign keys in a while, but that allows you to give a perspective, give foreign keys allows you to connect dimension tables with a fact table. Correct? In our example, we have product code, you can have city code, client ID. Those are all your foreign keys. It connects your dimension table with your fact table. Okay, if I have to see some examples, right? Sales transaction, the one that we have in the data model already, that's a fact table. Let me give you some more examples first so you can have a better understanding. You know, your bank transactions, that's like a fact table. You have a date of the transaction, you have what did you spend the money on, what was the amount of the money spent, and the balance, right? And it keeps on growing. Your inventory transaction, inventory, inventory transaction, right? Your inventory, like your product ID, quantity of the product going out, and the balance. Your PO table, correct? Your date of the PO, your PO number, and the total value of the PO, so on and so forth. Your invoice table. These are all your transaction tables. Give me a thumbs up if kind of this makes sense. And then we look at the dimension table. This is your transaction table. And after that, I might request you to share your fact table and just have a discussion so others can get an idea of what kind of transaction tables you would have.